He kōna e purangi tēnei nā te reo irirangi o Aotearoa.
No species other than humans have something like music. Other species have vocalizations that might sound a bit like music, but they're very, very different in their functions and in their design than the human music faculty is. Just the fact that we're doing it in the first place is like, wait a minute, what's that about? Why do we have this thing? Why are we listening to this in the first place? Why are we equipped to produce it and process it?
Kia ora, nau mai haramai ki te ao hurihanga. Hello and welcome to Our Changing World. Ko Clark and Cannon tēnei. Dr Sam Mehr is a psychologist at Waipapa Taumaturau, the University of Auckland. Now, here's some music, aka vibrations travelling as sound waves through the air. Think about what your brain is able to do as you listen.
It is very weird that, we hear that particular kind of vibrating air, and it sounds to us like all of this meaningful substance. And not just meaningful substance in sort of a wishy-washy, I love music kind of way, but like structured information. When you hear the Beatles play something, you can, in real time, while you're listening to it, separate out Paul McCartney's voice from John Lennon's voice, right? You can hear George Harrison's guitar, and it's not the same as the voices. You can hear Ringo playing the drums. Those are different sounds, and they all are playing together to make this piece of music that, makes you feel good or bad or makes you, cry or feel happy, whatever. But structurally, you're able to parse out these different components of what's being played, not just the different instruments being played themselves, but also the different musical features that are being played. So what counts as melody or what counts as bass line or accompaniment?
This is what Sam researches. This everyday phenomenon of how we listen to, interpret, and respond to music, which we kind of all take for granted. Some parts of what we can do with music make total sense from an evolutionary point of view.
When you are an organism with ears and you're in a natural environment, the auditory scene around you is a very messy environment. There are a lot of overlapping sounds, and your job as an organism is to figure out which sounds go with which objects and which agents. Humans experience this every day. If you just walk outside your house, you hear this massive, complex auditory scene, and without thinking about it at all, automatically our minds realize that, the humming that's coming from over there is like the engine of a car, and, the voices that are coming from over here are two people that are talking to each other and not one voice that's talking.
But others, like matching tones?
Some tones that are being sung in a particular melody sound like they fit, and other tones sound kind of weird. That's an interesting psychological phenomenon in its own right, and it has nothing to do with the physical properties of the vibrating air. Like, why do these tones sound like some are more stable than others? And why are they not just interchangeable?
When I show up in his office, Sam has the latest Billie Eilish album up on Spotify, which he's totally into. It's one of his side interests, delving into super popular music, trying to figure out what the secret sauce is.
I listen to every Billie Eilish album that comes out. I mean, she's great. And it's kind of wild why she's great to me. Like, some of the things when I listen to her new album that come out, it's like, it's maybe a combination of her brother who's doing all this production stuff, who's coming up with these really interesting, like combinations of instruments that are really unusual, but then quietly playing in the background. Anyway.
But it's not these highly produced songs that Sam uses to answer the fundamental psychological questions he's asking.
If you're interested in the sorts of musical behaviors that are more likely to be tied to specific aspects of natural selection, we have to go to more basic forms of music that are likely to have been present for long swaths of human evolutionary history. And that gets us more to behaviors that are less like what you listen to on Spotify and are more about what you do with your kids or what you do informally by yourself, singing in the shower or that kind of thing. It tends to be vocal music. It tends to be music that doesn't rely on a bunch of technology and can be produced just with your own body.
His own musical background began from a very young age. At 5, he started playing the piano. At school, he played saxophone in the wind band, and then he went to a music conservatory for university to study music education. Teaching in a class where he was working with toddlers alongside their parents sparked his interest.
It sort of became clear over the course of a couple of years of working in that program that there was a lot going on in the minds of these kids and the parents who were doing music with their kids. But I didn't really understand that much about it. I hadn't done a lot of psychology. I had taken like 1 or 2 courses that were required for the music education program. So I decided to get a bit more into it, sort of that direction. So I came to it through music teaching and then through sort of the cognitive science of child development.
He doesn't play professionally anymore. These days, he's got different musical influences in his life.
These days, most of the music that I do is my own kind of personal music listening and then doing music stuff with my kids. You know, I sing a lot with my kids. They have kind of weird taste in music. They get really obsessed with, you know, a movie music that they've heard and then will only listen to that for a very short period of time. It's like they'll get 4 days of, like, they saw Trolls, the movie, which has like Justin Timberlake and like a bunch of like good, you know, pop music. And so they've been obsessed with that for the last like 4 or 5 days, but then it's going to be gone soon. So anyway, we do a lot of music of just listening to music with our kids and singing along with it. And then when my kids were really little, we sang a lot, which turns out to be a thing that parents everywhere do. When you talk to parents of young infants, you find out that they sing a lot.
This is a clip of a lullaby from the Kanak people, indigenous to New Caledonia. It's from a music library and dataset that Sam and others assembled called The Natural History of Song.
We started this Natural History of Song project almost 10 years ago, I think, maybe more than that. And this is a project that just tried to take a systematic approach to what sorts of music turn up globally.
The Natural History of Song is a collection of texts from different cultures along with audio recordings and the context of those recordings. There's 118 songs representing 86 societies.
And many of these songs were recorded quite a while ago. So some of the recordings are over 100 years old. Some of them were collected off of wax cylinders when nobody was living like we're living now, you know, in an internet-connected city and that kind of thing. Some of these songs, you know, may in fact be thousands of years old and are passed along, you know, by oral traditions. But they come from many, many different societies, and that's kind of the point. You know, if you really are leaning into the idea that you're studying a human behavior, you should be studying it across lots and lots of groups of people. You're not just interested in people who live in cities. And you're especially not just interested in people who live in your city, right? You're interested in all the other ones, right? So that's part of the motivation for the approach of collecting recordings from all over the world.
There were other music collections, but Sam says they tended to be biased towards the types of recordings that are easy to collect, ceremonial or dance music, rather than the more intimate kinds of music.
We were trying to get around this problem by sampling songs from different cultures in this structured way. We wanted songs that were connected to particular behavioral contexts that we knew appeared globally, things like lullabies or healing music that shamans sing. Love songs that people sing to express, you know, their love for another person or in the context of, you know, weddings and that sort of thing. Or dance songs, which, you know, are indeed a big part of, you know, human life, but they're not the only kind of music that's out there. So once we had this set of songs, we could then use it in experiments to figure out not just what was the same or different about songs from different places in each category, but also how people from different parts of the world hear these songs.
They approached this in a few ways. One was to put the songs up online and ask people, what kind of song is this? Along with collaborators from Yale University, Sam runs a website called themusiclab.org. It's got games that people can do to test various aspects of musical ability. Your musical IQ, your ability to recognise different tones, your musical style. Behind each of these is a psychological question he and the team are interested in, and by gamifying it, they can get a whole heap of participants.
I think people aren't really aware of just the staggering numbers of people who are sitting on the internet looking for interesting things to do. At one point, themusiclab.org was posted on the front of Reddit. And we had something like 12,000 concurrent users. Not 12,000 people did the experiment. It was more like 500,000 people did the experiment in one day. 12,000 were there at the same time ready to play. I mean, and this is not a thing they're being paid for. This is not news. This is nothing, there was nothing topical in nature about what we were doing. Literally, it's just a fun way to think about how your own mind works. And people were, scrambling to do it. They were mad when the site crashed. They were upset that they couldn't do this free thing that was on the internet.
And one of these games is the World Music Quiz, which uses clips from the Natural History of Song collection and asks those taking it to guess what kind of song they're listening to.
We find that pretty much everywhere, a dance song sounds like a dance song, a lullaby sounds like a lullaby. A healing song sounds a bit like something's going on, sort of shaman-y, healing-ish. Although healing songs are not really a part of everyday life for most people these days, so it's a little bit harder for people to identify them, but they do have something in common with one another. They are reliably detected as healing songs and labeled as healing songs. But love songs are not. Love songs are much more ambiguous, and it's not clear whether that's because there aren't sort of universals in love songs. Maybe they're just highly variable. It might also be that the category itself is sort of fuzzy. Like there could be different types of love songs, and we haven't properly distinguished those types from one another. If you think of love songs on Spotify, it's sort of easy to imagine they could go in a lot of different directions in a way that lullabies don't really. Lullabies are very constrained. They're used for one thing, like calming, maybe two things, calming and, quieting or putting to sleep. And we've done a version of this experiment, for almost 8 years, I think, in different samples. We've run it on people on the internet. We've run it in the lab with, physical humans. We've run it with infants, where we see how the infants respond differently to lullabies or not. But all the people we had studied either were on the internet or were physically living in an industrialized city. So in this paper in PNAS, we collaborated with anthropologists, and they took these field recordings on these, rugged laptops, and they put them in canoes and went, down rivers to the middle of nowhere in Sumatra and in Ethiopia. And they studied people who don't have access to the internet and who don't have radios, who really have only ever heard their own culture's music. And one of the really surprising findings from that study is that the people didn't seem that different from our undergrads or our web listeners. The responses were pretty similar. A lullaby sounds like a lullaby really to everybody.
So why is this? What are the characteristics of a lullaby that make it easy to identify all around the world?
They're, by and large, the intuitive ones. Lullabies are quite uniformly slower than other songs. They have soothing, kind of slow contours. They're often sort of lilting or descending. They don't have a lot of rhythmic activity. They're not complex. They're very simple. They don't have a lot of words most of the time. One fun quirk about it that the late Sandra Tria, who's one of the sort of foundational people in our field, liked to comment on was that people often mix in very negative lyrics with their lullabies.
Just think about it. In the grim ending to Rockabye Baby, the bow breaks and baby and cradle both fall to the ground. Scary lyrics aside, because babies can't understand them, in experiments Sam ran in Harvard, the babies did respond to these lullabies. Of course, this isn't as easy as putting a quiz up online.
We brought the infants into the lab and we showed them videos of animated characters who sang either lullabies from the Natural History of Song corpus or other songs that were not used as lullabies, but that had some features in common. So songs that were sung by only one voice, that didn't have an accompanying instrument and so on. So it's a very tight control. One character is a lullaby singer, one character is a non-lullaby singer. The songs are pretty close to one another in their content, but the lullaby singer only sings lullabies that were actually used to calm down babies from around the world. And the question is, what happens to the infants when they listen to these songs? And the answer turned out to be quite simple. From a psychophysiological perspective, measuring things like heart rate, electrodermal activity, which is like how much electrical activity is on their skin, a measure of how excited they are or how upset they are, basically, and also their pupil dilation, all of these variables changed as a function of whether they were listening to lullabies or not, even though these songs were coming from cultures that they had never heard of, being small infants in Cambridge, Massachusetts, and in languages that they had never heard before either. So if it's the case that it's not just that people recognize these songs, but in fact the lullabies work to calm the infants down, then the question is, okay, what do they hear in the lullabies? And if they're hearing more of these lullabies that do work on the short-term basis, what happens in the long term? Are they easier infants to calm down? Are they more chill? Are they, more interested in music in general? We don't know. You have to run an experiment to find out. On the first question, what do they hear in these songs? Do they hear the lullabies just like we do? Do they sound soothing to the infants? Or is it just like, oh, mom started singing a lullaby, therefore I'm going to calm down? We don't know. We have to run some experiments. So those are two of the big next steps.
And this brings us to the baby lab.
This is the baby lab.
We head through the meet and greet room, furnished with soft chairs, play mats on the floor, and stacks of toy-filled shelves.
So this is where we do our listening experiments with infants.
I mean, for a baby, it's a very boring room. There's a lot of black curtains, but then there's a giant TV and some speakers.
And then this giant camera is what records infant behavior. So this gets hooked up here. And is pointed right at the infant's face so that we can get a very high-definition video of what the infant is looking at while they're watching and listening to, whatever we're playing for them.
And when you said about the heart rate and the electrodermal activity as well, is the infant also kind of hooked up?
Yeah, they're wired up. So they wear kind of a Fitbit-style device, and that records their heart rate and their electrodermal activity. And then we get their pupil dilation from the video of their face. The video is extremely high quality video so that we can see how much their pupil is changing size after the fact just from the video itself.
What age are these infants that are coming in?
As young as about 3 months. So they're very little. Well, at least the younger ones are very little. But we have run studies in this room up to about 14, 15 months old. So when the babies are a little bit older, we put them in a high chair. When they're really, really little, they sit on mom or dad's lap. And then mom or dad gets to wear big headphones that play other stuff so that they're hearing not what the baby's hearing. And that way they can't influence the baby's behavior.
PhD researcher Juliet Berry pops in to help start up the computer for us. She's not begun her experiments yet, but when she does, she'll likely use this space too.
I'm still figuring out the whole scope of it, but I'm really interested in when babies hear sounds, what are they paying attention to? We know that babies have this incredible capacity to learn language really quickly, and I'm really interested in the mechanism of that, of when they're taking in all of these different auditory sounds, what is it about the sounds that they're really paying attention to that help them kind of build up to eventually having a grasp on language.
And what kind of ages are you going to be focused on?
The younger, the better, but it's, it's hard to make really little infants pay attention to stimuli in a way that's super helpful. So probably going to be trying to get around 5-month-olds, but are probably going to start older and then work younger as we kind of work out the methods of the study.
So you would ideally want to be starting as young as possible, because when babies are born, their auditory system is already in place, right?
Even prenatally, we, have information about how babies are paying attention to their mother's voice and to music, and that, that starts even before they're born. I'm interested in looking at the age of between 5 months to a year, where they really start this process of their auditory system changing. And there's evidence on babies using what experience they have of the world to narrow kind of what they're focusing on.
You mean in terms of sound, what they're going to focus in on to listen to? Right.
For example, the different languages of the world have very different sounds to them. And so a baby in one sound environment with, for example, a tonal language like Mandarin is going to need to pay attention to different information than a baby who's learning to speak a language like English.
Can you just explain for me what a tonal language is?
Sure. So a language like Mandarin or Cantonese has different tones that relate to the meaning of the word. For example, the word ma, M-A, there's different ways that you can say that. In Mandarin, there's 4 different ways you can say it with a rising tone. Ma, I'm not a native speaker, so I won't try and do all of them.
Fair enough. Luckily, some of my wonderful RNZ News colleagues are native speakers. Here's Ruth Kuo.
Ma, 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 ma. 4 tones. Each tone has multiple meanings, but here is one example for each. The first tone, ma. The tone is high and level. One meaning is mother, ma. Second tone, ma. The tone raises like you are asking a question. One meaning is hemp or numb, ma. Third tone, ma. The tone starts mid, dips down, then rises. One meaning is horse, ma. Fourth tone, the tone starts high and falls sharply. One meaning is to scold or curse, ma. These tonal differences are crucial in Mandarin Chinese, as they change the meaning of the word entirely.
I mean, in English, you can use a sarcastic tone, which might, yes, kind of change the meaning, but not the actual words that are being spoken.
And so we're interested in studying also those differences in what babies are kind of doing as they're figuring out what kind of things relate to meaning in their environment.
Oh, that's fascinating. And so the language that the baby is surrounded by might also impact what they're focusing in on at different times during their development.
Yeah, because we know in adults, adults that aren't exposed to a tonal language have a difficult time even hearing those tones. For example, there's 8 tones in a Cantonese language. If you don't have any exposure to Cantonese, we know that adults have a really hard time distinguishing those tones. And so kind of understanding how that happens and when that happens is part of what I'm interested in.
One of the experiments happening now in the lab is how infants respond to tones that sound like they match, or not, to our adult ears. Juliet gets it up and going for us.
There we go.
So that's working, but it's not appearing on the screen.
Okay, yeah.
My name is Sunny. I've been learning some new songs for my friends. Want to hear them?
Okay, so this character is singing a song the infant hasn't heard before, which is just a randomly generated set of notes.
And when you say character, this is a yellow smiley face.
Who's dancing? So Blue Guy sings that tone, which sounds like it kind of fits pretty well, I would say, at least to my ears. And then they just kind of hang out here, and we'll be recording how much the infant looks at each of these 2 characters. And then as we do this more times, and the infant hears more songs from the yellow character, who's coming back now, in a new key. Now this character here is going to sing one. So Purple Guy sang a thing that did not fit very well. So now the question is, as the infant gets more and more information about the Purple Guy who sings not nice things and the Blue Guy who sings nice things, does the infant have any difference in their responses to these 2 characters? Do they look kind of warily at the Purple Guy and spend more of the time available looking at that one than the blue one? Or maybe vice versa. Maybe they look at the blue one longer because they like the blue one.
Purple is back again.
Yes, Purple's back again with a weird sound. So there is sort of a funny vibe to infant perception experiments. It's sort of like a whimsical weirdness, which I can tell by the look on your face that you're getting. So infants, especially small infants, really love looking at faces. So a lot of infant studies, especially with auditory perception studies, will pair characters who have just very clear, big eyes and smiles, so that the infants just look as much as possible at them. It keeps their attention. And because they're paying as much attention as possible to the whole thing that they're watching, differences in what they pay attention to within that set of stimuli can be really informative for scientific questions.
Can I just say that when you initially said like a blue person and purple, I mean, I say person, but smiley face, and that the tones were off for the purple, you know what? I don't think I would be good at this.
Well, that's the thing. There's subtle effects, and it may be that it takes sitting in front of these 2 characters for several minutes to really get the sense that the blue one does have a bit better fit than the purple one. It may be that it's too subtle, and the infants won't show anything at all. In which case, maybe they don't have the ability to detect the difference, or maybe they do, but the difference we're testing is too sort of fine-grained, and we need to be testing a coarser, a more obvious difference between them. One of the reasons,
science, right?
Well, right. Exactly. That's the science. I mean, that's sort of part of the game is that you can't know until you run the experiment. What the parameters of the experiment need to be in order to demonstrate an effect. And it may be that the effect doesn't exist, in which case there are no parameters that we could set up that would demonstrate the effect. So one of the reasons that we link up these sorts of experiments with our citizen science work is that we can use the same melodies with a large number of adults on the internet to figure out what is the kind of developmental target? What are infants going to grow up to be like? So what should we expect them to be able to do eventually that the adults on the internet can do? And then we can take that information and build it into these studies here in the lab to inform the sorts of decisions about that. Because, it is a subtle difference. So maybe it won't work. Like, we don't know. That's part of the fun.
Okay, so you're telling me I shouldn't feel bad that I didn't instantly recognize the difference in tone that is aimed at babies.
Yeah, no, you're all good. It's intended to be a subtle difference.
Okay.
The question is, can the infants tell that there's a subtle difference?
They've done this with 15 infants so far, with analysis to come. And they're also running a separate study that's aimed at that question of how parents singing lullabies affects the infants in general.
What we do in those studies is when a family is in like a music group, they're randomly assigned to do more singing for a portion of the study. During that portion of the study, we send them text messages, at a randomly selected time each day. And we ask, were you with the baby for the last couple of hours? Okay, if you were, cool. Did the baby cry? What did you do in response? Have you done any singing in the last couple of hours? Have you done any listening to music recordings in the last, couple of hours? Really direct, objective questions about what the infant is up to and what the parent's up to, more specifically with the infant.
And asking as somebody who doesn't have very good musical ability, is the quality of the singing by parents important?
No, not at all.
Infants
Infants seem to.
Interesting.
Yeah, no. Infants seem to just love being sung to. They're not very. They're not precious about how good the singing is. They just kind of like it.
They're not a discerning audience.
I wouldn't say so. And that's good. I mean, I think more often than not they really just like hearing their parents' voices. So singing is just another thing that mom and dad can do that presents the voice to the infant.
Yeah, I have a niece who sings Twinkle, Twinkle, Little Star to her baby brother, but quite aggressively.
Yeah, no, older siblings often do some of this singing stuff as well. It's a little bit of a different vibe.
Pinta, little star.
But yeah, no, I think infants are not discerning. They can in fact discern between things that sound different to one another. In fact, in the study, like in what you would run in this room, you could, for example, measure whether infants can tell whether a song is sort of better performed or worse performed. We haven't done that, but probably they're able to. They just don't seem to care that much about it.
Another PhD researcher in the lab, Marty Snarkus, is working on the next version of the Natural History of Song project. So he's expanding that collection, or corpus as he terms it, of music and information.
We have 10 times as many songs. The first corpus had about 118 songs. This new one has 1,007. Additionally, we've moved from 4 categories of songs to 10 categories now.
He'll do the same kinds of experiments as before with these, checking to see whether people can accurately identify what type of songs they are.
Currently, I'm working on a game, effectively, in which people listen to these songs and have to guess whether they're, for example, a dance song or a story song, and answer a few questions about, how it makes them feel emotionally.
But he'll also investigate the form of these songs.
Analyzing the music itself, getting acoustic features, and doing research into what is it about these songs acoustically that makes people be able to infer whether they're, for example, dance songs or lullabies.
Each of the songs comes with ethnographic notes about the language, context, and region. The long list was 2,000 songs, halved due to the need for this data about where the song came from and what it was used for. And Marty has listened to most of them.
There's some really interesting and, music that, is very different from, say, the pop songs we hear on the radio. There's one I'm thinking in particular, which is a choir from Georgia that sings a procession, and it's these beautiful sort of choral harmonies. Those are really, really pretty. One of the beautiful things about music is that it's very translatable, right? Or there's not even a need for translation. It's sort of described as a human universal language in some ways. Even dance songs from West Africa, we as, Westerners can really feel the groove and get into them as well.
Like Sam, Marty too is a musician.
I call it a bad habit of buying instruments I don't know how to play and playing with them. Right. And of course, it's called playing music, not, accomplishing music, right? The whole idea is to have fun and make sounds and see how they make you feel, to express yourself and stuff like that. In my own personal music making, I found this project to be really interesting because I've thought a lot more about when writing a song, what is the song for? What am I trying to do with this song? And trying to make that felt within the music itself, right? Like if I want people to dance to the song, you have to make it groovy, right? And if you want to tell a story, right, think about what is the story you're telling and how does music then express and induce emotions in people.
We're kind of at a moment where AI is just beginning to have the ability to create music. You can go onto websites and you can say, I want music of this kind of form. For you as a musician and also somebody who's studying, psychology of music and has this amazing catalogue of songs from around the world, how do you feel about that?
I find myself very critical of AI for a few reasons. One is the way that generative AI works. I think a not inaccurate way to describe them would be as plagiarism machines, right? There's a lot of music that is fed into these large learning algorithms that they then mix and match and learn from. When these generative algorithms create songs, the royalties for these songs go to the people who made the algorithm and not to the people who made the music that trained the algorithm. And another perspective I have that I've been thinking about a lot more since generative AI started becoming a lot more powerful and a lot more used is, right, why is it that we do music in the first place? Right, as Western industrialized listeners, we tend to have a very interesting relationship with music in that we are audience members to music and not creators and participants. But the real beauty of music is when people are able to come together and create music together.
Thanks to Dr Sam Mehr, Juliet Berry and Marty Snarkis from Waipapa Taumataro, the University of Auckland. Thanks also to Ruth Kuo of the RNZ China News team for recording the 4 tones of Ma. And of course, thanks to my niece Sophie Heher and her parents Ruth and Brian for recording her unique rendition of Finkle Finkle Little Star. Ko Clerkin Kananoho te kaio tu o tēnei hotaka I awhina mai a Phil Vine rawa ko Ellen Rikers. I produced this episode with help from Phil and Ellen. Sound engineering was by William Saunders. Liz Garton is executive producer of Our Changing World, and this episode was made with help from Otago Access Radio. I highly recommend visiting our webpage this week, rnz.co.nz/ourchangingworld, because we'll include links to relevant further information, like where you can play the games we mentioned, and an interactive explorer of the natural history of song collection, which is really cool. Tēnā koe I whakarongo mai. Thanks so much for listening. Ko Clerkin Kananaho. Have a great week. Kia pai, te wiki.
Enty Wenty Spider, time up a spout. Down came a rainer, wash Enty out. Out came sun and died by rain. Yeah.
Thanks, Sophie.